Okay, in this video, we're going to cover the 7.1, 7.2 worksheet. Let's start with number 1. We're plotting polar coordinates. I have 2 points, A and B. We'll start with A. Always remember, start with your theta. That's the easiest way to do this. So I'm going to go straight to 2 pi over 3, which is located right here. So from the origin, if our r is positive, you will be going towards that angle. If r is negative, you're going to be going away from it. So here it says -5. So from here, I'm going to go 1, 2, 3, 4, 5 away. Okay. For part B, remember this angle is not a standard angle. So what I ended up doing here was adding 2 pi, and I changed it to common denominator, and I found that that was the same as pi over 6. Pi over 6 is right here. So from the origin, and because r is positive, I'm going to be going towards that angle, and I'm going to be going 3 units. So 1, 2, 3, and there's my B. Okay. All right. For number 2, it says we're supposed to find 2 additional polar representations of the same point, but we need to make sure that our angle is between -2 pi and 2 pi. So we're changing this. So that means r can be positive or negative since there's no restrictions on r. So first thing I did was go ahead and put this in standard form. So I put 6. 6 is going to stay the same. And then I'm going to add 2 pi. And of course I changed this to common denominator. And my first point I found was this one. Okay. Then I used 7 pi over 6. And I went straight across to the theta in quadrant 1. Because remember, this is in quadrant 3. And I found that to be pi over 6. Because I'm going towards pi over 6, I need to make sure my r is negative so I can go back towards the 7 pi over 6. In other words, what I ended up doing on this one, 7 pi over 6 is right here. Instead of going in this direction, I went ahead and went exactly across from it, found that pi over 6, but remember, if you're going towards pi over 6 and r is negative, then that means you're going back. First thing I did was add 2 pi to change the angle into standard form. Okay. Then I used that 5 pi over 3. I went across into quadrant 2. Okay. If I look at my circle here, I just went directly across it. And if I was going towards this angle, a negative r means I'm going in the opposite direction. Okay. So I used this angle, went straight across, and found it to be 2 pi over 3. But then remember, you have to put a negative in front of the r, so it goes back in the opposite direction. The opposite of whatever r was given, and in this case, r is already negative, so a negative times a negative gave me a positive 3, and I left it with a theta that I found in this section. Topic 3 says convert rectangular coordinates to polar coordinates using special angles. Special angle ones will be a lot easier because that's something that's already found on the unit circle. Okay, so let's just look at this one here. First thing I ended up doing was plotting the point in the correct quadrant. You'll see it here. And then it says use your answer writing degree sign. So first thing I did was solve for r. So a squared plus b squared is equal to r squared. Evaluate. -2 squared is 4. This squared came out to 4 times 3. So r ended up being 4. Use the tangent opposite over adjacent, and you would find tangent has to be the square root of 3. Because we're in quadrant 3, you want to go back to your unit circle. You're going to look for where tangent is the square root of 3, which is located here. And since we're using degree signs, we're going to say that theta is equal to 240 degrees, which we have here. So I wrote it in polar coordinates, which means r theta. Okay. For number 2, we're going to do the exact same thing. I'm always recommending that you guys go ahead and plot it in the correct quadrant. -x, +y means we're in quadrant 2. Okay. Use Pythagoras' identity to solve for r. So -4 squared plus 4 squared is the square root of 32. And I solved that over here. 32 is 16 times 2. Square root of 16 is 4. Square root of 2 is still square root of 2. So I simplified that one. Okay. Then finding theta, well, theta is going to be negative 4 over 4, or in other words, negative 1. Since we're in quadrant 2, make sure your theta is in quadrant 2, is right here, so we're going to be using 135 degrees. Polar coordinates is going to be just your r and your theta. Okay. Number 4, now we're converting polar coordinates into rectangular coordinates. This tends to be the easier one. This is your r, this is your theta. You just want to use your formulas here and here. So if you know that this is r and this is theta, all you're going to do is plug in the formulas. X is equal to r, which is negative 4, cosine of theta, which is 7 pi over 4. Evaluate this using the unit circle, and you'll be able to get x is equal to negative 2 square root of 2. You're going to do the same thing for y, and then you're going to put it in xy form. For number 2 on this part, you're doing the exact same thing. You have r as 1, you have theta as being negative pi over 2. Plug it in, and you'll get your points. Okay, we did it a third time, exactly the same thing. Evaluate, and then you put down your x and your y. Those will be your rectangular coordinates. Okay, number 5 says we're going to convert this equation to polar form. Then solve the resulting equation for r. So the first thing I did was I put what y is equal to. Use the formulas on your reference sheet right here, and you can see that y is equal to r sine theta. So I put here r sine theta is equal to negative 2. I'm going to solve by r by dividing each side by sine. So then I get r is equal to negative 2, and 1 over sine is cosecant. Number 2, I'm combining my x squared plus y squared, that's equal to r squared, and then I have plus 2, and then x is equal to r cosine theta is equal to 0. When I'm looking at these two terms, I can see that r is in common for both, so I'm going to factor that out, and I have r times r plus 2 cosine theta. Now we can use the 0 property and set each of these equal to 0. When r is equal to 0, remember that is always included into this other equation. So all we have to do here is subtract 2 cosine theta on each side, and we get our equation of r is equal to negative 2 cosine theta. 4 on this one, we have y is equal to negative x. I ended up substituting what y was equal to, which is r sine theta is equal to negative from here, x r cosine theta. I brought the cosine part over to the other side, so I got this, and then I noticed that I have r in common in both terms, so I'm able to factor that out. You can set the products equal to 0 using the 0 property rule. R would be equal to 0, or sine theta plus cosine theta would equal to 0. Bring the cosine over to the other side, and then divide by cosine to both sides. Sine over cosine is the same thing as tangent. Negative cosine over cosine is the same thing as negative 1. And then you can see here, we're going back to the unit circle and finding what theta could be. So tangent is negative in quadrants 2 and in quadrant 4. So then here I said, well, it could be negative pi over 4, or it could be 3 pi over 4. Okay, so those are your 2 of your answers. All right. Number 4, what I did here was I went ahead and just evaluate what x is. X is r cosine theta is equal to 1. Divide by cosine, so r is equal to 1 secant of theta. Number 6 says convert the equation written in polar form to one in rectangular form. So now we're going opposite. We're given r is equal to 6, and we want rectangular form. So the only thing we can do here is square both sides of the equal sign. So r squared is equal to 6 squared, which is 36. Then we can say, well, r squared is the same thing as x squared plus y squared. That comes from this formula right here. And if you remember, this is going to be a circle. Okay. For part B, whenever you're given a theta, apply tangent to both sides of the equal sign. So tangent theta is equal to tangent 2 pi over 3. Evaluate tangent 2 pi over 3. That's going to be negative square root of 3. So here's negative square root of 3. And then I'm solving for y by multiplying x by both sides. So the x's cancel on this side, and then I have y is equal to negative square root of 3 times x. Okay. This is going to be a linear equation. Okay. For part C, we're using the formulas again. I'm saying that r cosine theta is equal to x, and x is equal to 3. Okay. This is going to be a vertical line. Okay, and D, I'm saying r sine theta is the same thing as y, so I'm just converting that and saying y is equal to negative 6, and that's going to be your horizontal line, right? Number 7 says to convert the equation in polar form to one in rectangular form. This is a type 2 problem, so it's similar but a little bit different. Number 1 on this topic, we're going to see that r is equal to 10 cosine theta. Notice that there's no r on this side of the equation, so what we want to do is multiply by r on both sides. So I get r times r, which is r squared, and then 10 r cosine theta. Now I can say that x plus y squared is the same thing as r squared, is equal to 10, and now r cosine theta is the same thing as x. You can leave the equation like this. For part B, all I'm going to do is take the denominator and multiply it to the other side. So I'm going to get r times this entire denominator is equal to the numerator, which is just 9. Now that I distribute the r into the parentheses, I'm going to have this equation right here. R cosine theta you can replace with your x. R sine theta you can replace with your y. You can go ahead and leave it like this, and it's going to be a linear equation. Part C, notice that there's no r with the sine theta, so you're going to multiply r by both sides again. You'll get r squared is equal to negative 4 r sine theta. R sine theta is the same thing as y. R squared is the same thing as x squared plus y squared. And then you can also leave this formula like this. Number 8, graphing. These are actually the simplest in my opinion. Whenever you have theta, look for that angle on your graph. Theta is right here. And draw a line straight through the origin. Okay. For part B, you need to evaluate this. This is the same thing as y, so y is equal to 6. Just look on your graph. Remember, this is your x-axis, this is your y-axis, and it's saying y needs to be equal to 6. So y is equal to 6 right here, and draw your horizontal line. We're going to be graphing the circles. So here, the first thing I'm going to do is notice that I have a cosine theta. Remember, cosine is the same thing as like x, so what we're going to be doing is graphing on the right side or on the left side. Because the 2 is positive, we want to make sure to use the positive quadrants for cosine. And so our circle is going to start at the origin, go out to 2 units, and the circle will be right here. Number 2, it has r is equal to 4 sine theta. So sine theta means it's going to be either drawn at the top or it's going to draw at the bottom. Because 4 is positive, we want to draw the circle in the quadrants where sine is positive. Sine is positive in quadrants 1 and quadrants 2. So I'm going to go start at the origin, and I'm going to go out 4 units in my circle. Number 2, I'm going to go ahead and substitute. R cosine theta is the same thing as x. X is equal to 5. Remember, this is your x-axis. Go to your 5 and then draw your vertical line. On part B, it says r is equal to negative 6. Because there's no sine or cosine, that means it's going to be a circle that starts at the origin. So all you're going to do here is have a radius of 6. So I'm going to go out 6 this way and out 6 this way, and then that's where my circle is going to be. All right, that concludes the 7.1, 7.2 worksheet. Let me know if you have any questions.